All right, so in this question we have a distributor wanna verify that actually the bars of waters are equals to 1 gallon of volume, right? So what he gonna do, he gonna select 45 bottles. He gonna take the mean of water in there. So he gonna find out that it gonna be 0.993, and that would be your X bar, right? Now the 45 bars, that's N. And as well, they mentioned that they know the standard deviation, right? And the standard deviation is going to be 0.03. So in this case, sigma is equal 0.03 and is known, right? So we have two factors here. Sigma is known, N equals to 45, greater than 30. So here we're going to use the Z table, right? Now let's put the variable that we have. So we have X bar is going to be 0.993. The N was 45. The sigma is known and is equal to 0.03. And the mean is going to be 1 gallon. All right. Now the method that we're going to be using is the traditional method, which is going to compare the Z critical. All right, so we're going to compare Z critical here and Z stat. All right, okay, let's start with step number 1. And we want to mention the hypothesis testing. So step 1. And H0 will be, and you notice here that this is our claim. All right, so, and they use the word is in mathematics will be equal sign, right? So your hypothesis testing will be the mean equals to 1, and this is actually the claim. That's what we want to verify. And H1 is the mean will be different than 1. All right, so the opposite statement. Now, because we used here equal sign and here different, this is a two-tailed test. Two-tailed test, it means we're gonna have half of the alpha here and the other half of the alpha here. So this is gonna be alpha over 2, and this is as well alpha over 2. All right, we're gonna see it later on in the exercise. What is it, right? Now, the threshold where the alpha stop, this part here and this part here, whenever you hit the Z axis, this point here is going to be Z critical, and this point over here is going to be Z critical. So in other words, the value of the alpha will lead you to the value of Z critical. And because we are using two tails, we're going to have two Z values. All right, so this is step 1. We're done with that. I don't see the alpha here, so maybe you're gonna be on the exercise. So let me switch to the question and plug in the first answer. And here, there you go, the alpha is given over here. So this is gonna be the mean equals to 1 gallon, and H1 will be the mean different than 1 gallon. And as you notice here, that alpha is going to be 0.05. Right, so let's verify this answer first. All right, good. And the second step is Z stat, right? Okay, let's add the alpha to our information. Alpha here going to be 0.05. So what the meaning of this? If I take the alpha, which is 0.05, and divide by 2, this is going to be 0.0250. So this is alpha over 2, 0.0250. Now, in order to find the z critical, I just need to use the z table. All right. So remember, this is a probability. So I need to look inside the z table. All right. 4 digits is fine. And I need to read on the sides what will be the z critical for that. Now, usually the table give you the left tail. So I always focus on this side. All right. So this is the side that you're looking for. All right. So this area here, all right, is equal to 0.250, 0.0250. So let's go to the table. And here, as you notice here, I'm looking under the small tail. So you see this is a small tail like the left side. And the value of that should be equals 250. And you can see it is right here, right, 250 right here. So if I read it, this is going to be minus 1.9 and 6 here. So minus 1.96. Going back, so according to my table, this is going to be minus 1.96. And by symmetry, because this is 0, it's going to be 1.96. So that will complete the second step. And the second step, find the critical values, all right, from the appendix. So step 2, we get the alpha equals 0.05. We're gonna, because we have two tail, we get the alpha over 2, it's gonna be 0.0250. We're gonna use the z table, and from the z table we end up with z critical, sorry, equals to plus or minus 1.96. Okay, so the third step, we wanna calculate the test value. All right, so this is z stat. So how can you find z statistic? So z stat is really easy. You just have to use the formula. The formula of a center limit theorem, it can be x bar minus the mean divided by sigma divided by radical n. But I'm going to use parentheses. And let me remind you that we have other values here. So this is x bar, this is the n, this is sigma, and this is the mean, right? Let's plug them in. So x bar is going to be 0.993. The mean is going to be 1. Sigma is going to be 0.03. And divide by radical 45. And you might want to leave everything to the calculator. We're going to use the parentheses. 0.993 minus 1. Close the parentheses. Divide, open the parentheses again, 0.03, divide by square root, and 45. Make sure you exit the square root before closing the parentheses, and enter. So we end up with the value minus 1.565, minus 1.57, right? Okay, so we get the z statistics, we get the z critical. So right now we can go and make a decision. All right, so we might need a chart here. So the story that we didn't finish here, that if I am in between these two thresholds, do not reject 80. However, if you are outside this side or this side, you're gonna reject 80. Okay, so now how can we make a decision is just by placing the z stat, and is equal to minus 1.57. So maybe you're gonna be somewhere here. Z stat equals minus 1.57. And you notice he's on the negative side. However, he's not far enough to cross the minus 196. So we are within the not reject zone, right? So decision, therefore do not reject A0. All right, so step 5, if we did not reject A0, so we did not have enough evidence to reject it, right? And it happened to be do not reject A0, that's the claim. All right, so we do not have enough evidence to reject A0. So always you have evidence to reject A0, all right? So we are supporting the claim, all right? And finally the conclusion will be A0 is the correct, we cannot reject it. It means that the mean is actually equals to 1 gallon, all right? So that's the statement that we had in the beginning, right? So this is the statement, right? This is A0, we did not reject. All right, so now let's go to the exercise back, put the values. So this one, z stat, all right, so z stat is gonna be negative 1.57. Check it. Right, good. Now the critical value, we found it is two of them, which is 1.96. So we can use plus or minus here, and 1.96. Check it. Good. All right, so are we rejecting? No. Fail to reject? Yes. So you're gonna be either B or D. All right, as we said, do we have enough evidence? We don't. So there is sufficient evidence for D, and B, there is not sufficient evidence, so we're gonna go with B. All right, okay, now they are asking us for the p-value. So how can I get the p-value? I didn't count it yet. So if I go back, the p-value is always deducted from the z-stat. So from here, from this, remember you are in two tails, so this value is going to give you the p-value divided by 2 from the table. All right, so let's see, this is my table, minus 157, so minus 1.5, 1.5, and 7 is right here, so this is half of the p-value. So it's going to be 0.0582. So here it's going to be 0.0582. So now, if this is half, the p-value will be the double of this. All right, 2 times this. This is 4, 6, 1, 1, and 0. All right, so this is my p-value. Okay, plug it in and see. 0.114, I think. Check it. Okay, so it seems here that we get this number a little off, and I think because here we had minus 1.57. So if you remember, whenever we calculated, the number was minus 1.565. All right, whenever you round it is correct. However, this is gonna make our p-value a little wrong. So I will have to show you how to do it with the calculator to avoid these small mistakes. How can I use the calculator to do this one, right? So the calculator is equipped with a test. So what you're gonna do, you go to start first, and you go to tests, and then you're gonna go to one z-test. All right, we are using the z-test, and enter. So here you're not going to enter the data because we have no data to enter. However, we have the stats instead. So what you're gonna do, you're gonna enter here the mean mu0 is 1. Then you're gonna go to sigma, you're gonna put 0.03, that's the value that we have, and then you're gonna go to X bar, you're gonna put 0.993, and then you're gonna enter the N, which is 45. And then this is really important. So you're gonna decide whether it's one tail, two tails. The first one is gonna be a left tail or right tail. All right. So obviously we are using different than mu0, different than 1. So mu different than 1. That's high h0. That's a0. And I'm gonna enter and then go to calculate. So once I calculate this, I will get other values. So you see the z statistic, which is minus 1.565. All right, we talk about it. The p-value here is going to be slightly different, which is 11.75. So that's what I'm going to enter right now, 11.75, and I'm going to check it. Oh, round to 3 decimal points. All right, so if I round to 3 decimal points, it's going to be an 8 here. So still the other one wrong. So check, and that's correct. Okay. Now, that's how you use the calculator, right? So we want to make a decision whether accept or reject. So this is what is called the p-value method. And the p-value method, what does, it just compare the p-value to the alpha value. If I have the p-value smaller than alpha, then reject a0. Otherwise, I do the opposite, which is do not reject. So what we have here, the fact that we have 0.1175, the alpha is 0.05. So obviously this statement is false. So if it is false, that means not correct. The conclusion will be the opposite. Do not reject a0. And again, if we did not reject a0, not sufficient evidence. All right. So that's the p-value method. You compare the p-value with the alpha. Now going back to the conclusion, we did not reject, failed to reject, so either B or D, and there is not sufficient evidence in D, so that's what we are looking for, and check, and done. Now he's asking you to construct the 95 percentile interval, and we could use a formula here. All right, so because we are looking for the 95 percentile confidence interval, and it happens that this is the same thing as saying alpha equals to 5%, and actually this is 0.05. That's our alpha. So the z alpha over 2 that we have here is actually going to be 1.96. all right, is the same alpha that we used for z critical. Now the other values, we know them, so this is going to be 0.03, this is going to be a 45, this is going to be 1.96, and this is going to be 0.993, and the same over here. The only thing difference is the minus sign. All right, so we are looking for this boxing of the mean. This is going to be 0.993 plus 1.96 times 0.03 divided by radical 45, and from the other side it's going to be 0.993 minus 1.96, and here is 0.03 divided by radical 45. All right, so just leave it to the calculator. All right, so the one on the right is going to be 0.993 plus 1.96 times, open the parentheses, 0.03 divided by square root 45. Okay, so this is going to give me 1.1 gallon, 0.0017, I think. Right, 7 again. And the second one, so the second one, you don't have to change it, just change the plus sign into minus. So the plus sign here, change it into minus and enter, and that's going to be 0984. all right, so I think we can round this into 1.00. all right, let's plug it in. So they want 4 decimal places, so here I'm missing one more. All right, 423, so 42. all right, 0.9842, and here gonna be 1.008. right, this is great. And then the conclusion here, compare the result A and C. And what are the conclusion? So usually you go with the same. You shouldn't have any contradiction here. And the reason here because if you make the 1 gallon is actually between this interval, so we are not rejecting, we are accepting A0, right? So the two conclusions are the same. Okay, that's all.